Okay, we want to solve this problem of IMO second problem, IMO 2023 with hidden tangent. First, I explain this hidden tangent here, and also you can solve these two problems as homework. This BMO round 2 2017-2018 and this BMO round 2 2020-2021. Both of them can be solved with the same idea. So let me first explain for you this part. Hidden tangent is what? If we have a triangle ABC and let's draw, for example, triangle ABC, and then we have a tangent, for example, this tangent to this triangle. Then we can say that, then we call it A, B, C, and we call it P. A1 equal to C here, it's an important theorem. Angle A1 equal to C if and only if PA squared equal to PB times PC. PA, or we can say PA will be tangent to circumcircle of ABC. So let's prove it. First, we prove from left to right. Angle A1, so pause the video and try to prove this part on your own. As a hint, you can use similar triangles. So angle A1 equal to angle C, angle APB equal to angle APC, because both of them equal to P. So by two angles, we can find two similar triangles. Try to find the two similar triangles here. Triangle ABP is similar to which triangle? APC. And then we can say what? We can say PB is corresponding to equal to C, AP equal to this part. We can say in this triangle APB, AP is corresponding to this angle PC. So if we cross multiply AP squared or PA squared equal to PB times PC. So we prove from left to right, from right to left, you can use contradiction, or we can say we know PA squared equal to PB times PC. We can change it to PA over PB equal to PC over PB. And also angle APB equal to angle APC equal to P. So by which criteria we can say the two triangles ABP and APC are equal? SAS, two sides and an angle between. Then because these two triangles are similar, we can say A1 equal to C. We can call it is so much important. When you see, for example, these two angles equal, you can use this relationship PA squared PB times PC. And also if PA squared equal PB times PC, you can find these two angles equal. It is so much useful in many problems. We call it hidden tangent. And let's solve these problems. And this is homework 1. Homework 2, if you had question or wanted hint for these two problems, you can feel free to send a message to my WhatsApp number in the description and comments. Also, if you wanted to learn, there are 40, 50 important ideas in geometry and also other topics. If you want to learn them, feel free to send a message to my WhatsApp number in the description and comments. So let's try this problem of IMO. Okay, it says let ABC be an acute triangle with AB less than AC. Let omega be the circumcircle of this, big omega, circumcircle of triangle ABC. Let S be the midpoint of the arc CB of omega containing A here. So we can consider what S is here, midpoint. And it says the perpendicular from A to BC meets BS at D. So if we consider A to BC, this perpendicular meets BC at D, this point, and meets omega again at E, which is not A. The line through D parallel to BC. Okay. Meets what? Okay, meets line BE at L. Okay, so here BE at L. You know the circumcircle of triangle BDL by omega. So this green circle is omega, small omega. Let omega meet small omega meet big omega again at P, which is not B. So this point is P. Prove that the line tangent to omega at P. This line meets the line BS on the integral on the internal angle bisector of BAC. Okay, so we should prove these tangents, the angle bisector of internal angle bisector of AM. Let's consider this. And BS, they are concurrent. These three lines: internal angle bisector of A, common tangent through P to this green circle, and also BS. We want to prove they are concurrent, for example, in N. How we can prove this? One approach, let me tell you, one approach is approach one. Is that we consider this common tangent and this BS and prove that, for example, AN is internal angle bisector. Okay. One approach is this. Means what? We draw two lines and prove the line, the third line. For example, we draw BS and this tangent through P to green circle and the intersection is N. And we prove that AN is internal angle bisector. Approach 2 is what? Is that we prove that AM is angle bisector and we draw BS and we prove that NP is tangent to green circle or small omega. We call it small omega. For example, this is big omega is tangent to omega. We prove this. Here in approach 2, because it is if we consider AN equal to angle bisector, we have a lot of things related to angle chasing, and it will be useful for proving what? For proving that NP is common tangent. So let's analyze the problem. Here, let's move. We want to consider P. At first, try to find this angle. When we draw, we want to find, look, at first we consider S, then we draw BS, then we draw this altitude, and then we connect EB, then L has been created, then P. So at first we should find what's the property of P. If we connect these forward, we know this angle equal to this angle. This angle is what? Because it is these two things are parallel, this angle equal to this angle. This angle equal to what? Because these two angles are equal because they see the same arc on small omega, green circle. This is equal to this because this line is parallel to BC. This is equal to this one because on big omega on pink circle, they see the same arc EC. And let me draw this. And this is what? It is 90 minus C. Okay, because it is C, it is 90. So this one is 90 minus C, this one 90 minus C. So we understand that P is 90 minus C. So we can remove green circle. P is a point on arc AP such that BPD is 90 minus C. So we can remove extra things. So it will be easier to solve. Okay, so let's paste it here. Let's paste on this board new figure. Okay, and now we can erase this board. Erase this board, this board, this board. So we have this angle. Now we can also erase all these parts. So we work a bit on sentence, a bit on assumptions. And we know this angle is 90 minus C. Because we know this angle 90 minus C and we know P lies on this circle. So if we continue, we can find the arcs. Why? Because this part is 90 minus C, so it is what? 180 minus 2C. So let's consider this part is 180 minus 2c because it is twice this angle. Because it is c, it is 2c. Okay? And because these are 2c, 180 minus 2c, we understand, for example, if we have EF, we understand that AF is semicircle. The sum is 180, 2c, 180 minus 2c. So because it is this, if we draw AP, we will understand that this angle is 90. Okay? So let's consider, let me copy this part and then I can erase these arcs. These parts. Okay, so this angle is 90. I want to prove what? I want to prove that NP is tangent to what? Let's see here. NP is tangent to this circle. So we've selected approach 2. NP is tangent to omega. So I should prove NP squared by hidden tangent, the thing we've considered. NP squared, why? It is equal to ND times NB. Okay? So here also we can say y np squared. We want to prove y np squared equal to nd times nb. Now let's do some angle chasing. I want to find all arcs, all angles that are possible. So this part, because this here is what 2c, here is what 2b. So 2c plus 2b, and s is midpoint, so 2s plus 2b over 2, it will be b plus c. So this part will be b plus, because the whole arc is 2b plus 2c, s is midpoint, so it will be b plus. This part is what is 2b, because it is b, it is 2b. 2b minus b plus c will be b minus c, so we understand that it is b minus. Now we know it is 90, so this part is 180, so it is a plus b plus c. If we add these two things, it will be 2b, so I should place a plus c minus b. So it will be, this part will be a plus b plus c, 180. Now, because it is a half angle bisector, so it is a. So here it will be what? B minus. This part is what? Let's consider first, we know it is a half. This part is 90 minus b, because it is b. 90 minus b times 2. 180 minus 2b. 180 minus 2b is what? 180 minus 2b, you can say it is equal to a plus b plus c minus 2b. So it will be a plus c minus b. So we can erase this and write it like this. A plus c minus b. And this part equal to this part, we know m is midpoint, so the remaining part also equal. So em is also equal to b minus c, this arc. So we found all these arcs. And look, we have b minus b minus c, b minus c. We can find many parallel lines. For example, AE is parallel to SM, or AM is parallel to SF. Now, as you can see also, the angles that see same arcs, equal arcs are equal. So this angle, that the arc on opposite of that is b minus c, equal to this angle, the angle that see that side, that arc. Okay, so because of these two equal angles, we found another hidden tangent. NA is tangent to circumcircle of BDA. So we can say NA squared equal to ND times NB. So we've used some angle chasing and we found another hidden tangent. So by this word, we understand that we should prove that we consider these two things, NA equal to NB. And as you can see, if I consider this one, for example, K, triangle APK is a right angle triangle. If you consider midpoint of hypotenuse, NP equal to NA equal to NK. The proof is easy. So if you have a right angle triangle, if we draw median, then we can say like this. Some it is A, it is B, it is C. It is right angle triangle MA equal to MB equal to MC. And in general, if we have MA squared median through A, it is B squared over 2 for any triangle, plus C squared over 2 minus A squared over 4. And also by this formula, and you can prove it by Schwartz theorem. There are about 40-50 important formulas you should learn that are useful from basic level to highest level. If you want to learn them, as I said before, feel free to send message my WhatsApp number in the description and comments here. My Pythagorean theorem, if it is right angle triangle, A90, so MA squared. Here B squared plus C squared is A squared over 2 minus A squared over 4, equal to A squared over 4, so MA is A over 2. So median is half of hypotenuse. Okay. Now we can say you should prove NA, N is midpoint. If we prove from NA, NP, NK, if we prove two of them equal, the problem will be solved. So we should prove NA, let me write it here. We should prove NA equal to NP or NA equal to NK, or we can prove, let me move it left, NA, NP, NA, NK, NP, NP, NK. If we prove any of these two, any of these equalities, the problem will be solved. One of them is enough. Now here, we said that B minus C, B minus C, B minus C, we have similar triangles. And we can use some of them. Okay, so let me place it here. Okay, one thing, for example, we want to try to find, for example, for NA and K, you can find triangles, similar triangles that contain NA and K. For NA, this line, because B minus C, this one is parallel to AE. So AE is parallel to SM. So we can say which triangles are similar. Triangle ADN is similar to triangle SNM. So because of these two triangles that are similar, you can say NA over what? NA over this angle NM, equal to ND over NS equal to AD over SM. And for NK, we can say this triangle, this line AM is parallel to SF because these two arcs are equal. So because AM is parallel to SF, we can say triangle DNK is similar to triangle, what triangle? DSF. Or we can say Thales' theorem or Thales' theorem. Here, NK over SF equal to dn over ds equal to dk over df. Now in this part, we want to prove why nk equal to na. So here I write sf over nk equal to, I consider reciprocal of first two fractions here, ds over dn. ds, I can write ds equal to dn plus ns over dn. So it will be 1 plus ns over dn. And if you consider ns over dn, I proved ns over dn is what? From these parts. Equal to reciprocal of this. nm over na. Equal to 1 plus nm over na. If we use common denominator, na plus nm. Na plus nm is am. Is am over na. I want to prove why na equal to nk. So, because I know these two fractions are equal, so I should prove that, because I want to prove denominators equal, it is equivalent to prove numerators are equal. SF equal to AM. SF and AM, both of them are chord of this circle. So if I prove the corresponding angles equal, the problem will be solved. So arc SF, or let's say SCF from this part, is B plus C A plus C minus B. So it will be A plus 2C. Arc SF. Now arc AM. If I consider ABM, arc ABM, it will be arc this part, which is 2C because it is C, 2C plus this part. Because it is A over 2, it is A. So it will be plus A. So arcs of them equal. So we proved that SF equal to AM. So because SF equal to AM, then we proved NK equal to NA. And it was exactly the thing we wanted, NK equal to NA. So it is median of this right angle triangle. So PN equal by angle chasing, you can prove this. Also here, I've told you this relationship. Okay, so we proved this problem with this idea here. And as I told you, there are two homeworks that you can solve them. Homework 1, this problem of British Mathematical Olympiad. After I can say USA, USAMO, the most prestigious exam is national exam is BMO, British Mathematical Olympiad. Two problems of round 2. Also, this idea is useful in many problems of AMC, AME, USAMO, and we will solve more problems from this idea. Okay, and if you had any question about this topic, about this idea, wanted to learn more ideas, wanted to solve more problems or more ideas, feel free to send message my WhatsApp number in the description and comments.